Unit 4, Risk and Return, Lecture 11, Portfolio Performance Measurement, Part D. So the second risk-adjusted performance measure we're looking at is Treynol's measure. And Treynol's measure is very similar to the Sharpe measure, with the only difference being that instead of using total risk or standard deviation as its risk measure, it uses beta or market risk. So it's still looking at excess returns, which is the return on the portfolio over and above the risk-free rate, and it's dividing that by the portfolio's beta. And again, we want to look at how high this number is, because the higher the number, the more skilled the portfolio manager, the lower the number, the more risk taken in generating the return. Now we're looking at Jensen's measure, or Jensen's alpha, and this is the return that is generated over and above the return predicted by the capital asset pricing model. So if we took the portfolio, its beta, and we compared the return generated using CAPM to the return actually generated by the manager on the portfolio, any positive return is considered active return, and that is Jensen's alpha. Okay, so it's the return that is generated by the manager in excess of the return predicted by the capital asset pricing model, and it's an active return. The final risk-adjusted performance measure that we will be looking at in this lecture is the information ratio. And the information ratio just looks at taking Jensen's alpha, or the active return, and dividing it by non-systematic or diversifiable risk in your portfolio. So you're looking at the ratio of abnormal return generated by the manager per unit of risk that can be diversified away by holding a market index portfolio. So in other words, how much of abnormal return are you holding, and is there any diversifiable risk that you still have, which you could have gotten rid of? And it's a ratio of those two. The next 3 slides look at an example and how we calculate all of the various risk-adjusted measures that we've talked about. We're now going to delve more deeply into which risk-adjusted measure is most appropriate. And it all depends on what investment assumptions you are using. If the portfolio represents the entire risky investment, then the Sharpe ratio is the most appropriate measure. If the portfolio is one of many combined into a larger investment fund, then either Jensen's alpha or the Treynol measure become appropriate. And the Treynol measure is appealing because it weighs excess returns against systematic risk. So when you're looking at a portfolio in which you can diversify away risk, then the Treynol measure is more appealing. So now we're going to look at which performance measure is appropriate in 3 scenarios. Now we have Jane, and she constructs a portfolio P, and she holds it for a considerable period of time. She makes no changes in portfolio composition during the period. In addition, we're going to suppose that the daily rates of return on all securities have constant means, constant variances, and constant covariances, and this assures us that the portfolio rate of return also has a constant mean and variance. Now we want to evaluate the performance of Jane's portfolios in 3 different scenarios. In the first scenario, Jane's portfolio represents her entire investment fund, and the benchmark she's using is the market index or another specific portfolio. In this case, it's the entire risky portfolio. As mentioned before, the most appropriate performance criterion in this instance is the Sharpe measure of the actual portfolio versus the benchmark. In the second scenario, Jane's portfolio P is an active portfolio, and it is mixed with the market index portfolio M. Because the information ratio looks at the active return per unit of diversifiable risk, it's actually a more appropriate and correct performance measure than the Sharpe measure in this case. In this, the third and final scenario, Jane's choice portfolio P is one of many portfolios combined into a large investment fund. And as we've mentioned before, in this instance, the Treynor measure is the most appropriate criteria. Finally, we're going to look at some portfolio performance statistics and evaluate those. So the table below summarizes various portfolio performance measures for 3 different portfolios, and we're going to look at that and evaluate their performance. So looking at the statistics from the previous table, we can draw a few conclusions about P, Q, and the market portfolio M. In looking at betas, we can actually conclude that portfolio Q is more aggressive than P. In fact, it's more aggressive than the market. And P seems to be a much more defensive sort of portfolio with a beta of 0.69, which is actually less than the market beta of 1. In addition, P also seems to be better diversified because its residual standard deviation is 1.95% when compared to that of Q, which is 8.98%. And interestingly enough, both portfolios outperformed the benchmark market index, and this is evident from their large sharp measures. If we're looking for a portfolio to serve as our entire investment, then Q is better because it has a higher sharp measure and a better M squared. If P and Q are competing for a role as one of a number of sub-portfolios, Q is also better because its Treynor measure is higher. However, if we're looking for an active portfolio mix, then P's information ratio is higher, making it the better choice.